For anybody who doesn't know me, my name is DeVore. I've been working for MoTeC now for 8 years, and I've done mostly engine calibration stuff in my time there. And I've done American Le Mans Series, Grand Am road racing, 24-hour endurance stuff. I did got the ECUs approved and worked with the NHRA Pro Stock motorcycle guys for a few years and got that program up and going, and been doing some production car stuff, so it's sort of all over the board. Some airplanes, boats, you name it. I've had probably had an ECU in it and tried to figure out how to make it run. John Deere tractor, got one of those going too.
Turbo Harley.
Turbo Harley. So I have a lot of experience with a lot of different applications, and how that's beneficial, I suppose, is I've had to come up with a lot of creative solutions to problems, or sort of be a bit innovative in new strategies and things like that. And what I've done is taken this kit and developed it specifically for motorcycle drag racing. If anybody has experience with our M800, our older generation stuff, it's basically everything to run any vehicle all in one box. And the problem with that is that although it's very useful and versatile, it's complicated to use. It just gets overwhelming with the amount of stuff that's in it. So one of the focuses for this kit was to make it simple, to trim out all the stuff that's not necessary for a motorcycle drag racing application, but also leave in and simplify the functions that everybody needs. So what the result of that is this M130 plug-in kit. Like I was mentioning, just for anybody that wasn't here, here's what the kit looks like. You all can come up and pick it up and play with it. Somebody gets to take it home. This is the entirety of the kit. There is nothing else. This will do boost control, this will do nitrous, this will do shifting. It'll allow you to add spares and expand your system beyond the basic sensor package that comes on a production bike. There's no other additional electronic boxes that are required. Everything's handled inside this system. The way we migrate this from different bike makes and models is by having a different adapter box. So, you know, whoever gets this kit needs to tell me what sort of bike they want to run it on, and then I'll give you the associated adapter box. And what this adapter box allows us to do is to have this one, for example, as a mating connector to a stock harness for a Gen 1 1000. We cover Gen 1, Gen 2 1000s and Gen 1, Gen 2 Hayabusas. And this box can actually be used with a few wiring modifications to do some of the Kawasaki's. We're working on one of them right now to find out the exact pin changes. It's a little bit more work, but it does work. Future expansion for bikes that seem to have some promise, we'll build new adapter boxes, and then the rest of the kit can remain the same. We have the ability to do, this ECU is so powerful, it'll have the ability to do things like the drive-by-wire bikes that are coming out. You can leave those drive-by-wire throttles on it, and this ECU will be able to control them. And then you can actually do some very interesting things like profile the torque map as you go down the racetrack, and not have to use ignition retard and some of the other functions that are currently being done. Go ahead and move on. So I jumped ahead a little bit. The idea behind the kit was to do something focused on your guys' needs, and then I'll go into some of the specifics of what those things are. Go ahead. One of the benefits, or probably one of the main benefits of this system is, like I said, everything's done in one box. You have got nitrous control, boost control, shifting, all being done in the same unit. And why that's such a big benefit is you can actually data log all of what's going on You can diagnose any problems. You don't have things like wiring splices. Mentioned yesterday when I was doing this, the amount of the inline wire crimps that I see and the amount of times I've seen them fail. It's a quick solution, but not really one that's designed for the type of racing that you all are doing. So one of the things about this kit is there is no splices in here. This is all made out of military grade wiring. It has a diesel resistant shrink over it. Obviously it can't go all over the entire thing and still be serviceable, but there are no splices in here. They're all direct connections. We did that intentionally. We did all of our splices or anything inside this box so that we can provide a safe, reliable solution for the wiring side of it. So like I said, we're going to go through some of these in a little bit more detail in just a minute, but the point being that you can do everything out of one unit. You can data log it and see what every system and the rider is doing at one time. Go ahead. So some of the features that I've touched on already, you can do manual or automatic shifting, and these are the things I'm going to go over in just a second. You can do progressive nitrous, anti-lag, boost control. I'll go over the fuel model, some data logging, chassis sensors, knock control capability is in there. Made note yesterday that none of the bikes that I've seen so far have a knock sensor on them, but one can be added and can be used for knock detection, and then the ECU can actively respond to it. Closed loop fueling, it can make fuel corrections going down the racetrack for you. And one of the things that also makes this box really interesting is we've taken every additional resource that the ECU has, inputs and outputs, and run them into this spares connector. There's a third connector on this side that in the kit you see is open. But anything additional you want to add, shifters, boost controllers, nitrous controllers, all gets wired into here. You don't have to splice into the harness anywhere. You just build a little subloom for what you need out of this, and you have access to everything else that the ECU has available. Go ahead. And it can be password protected. So if you are a bike manufacturer, you build bikes for somebody, or you're doing tuning, you can actually lock them out of it so that you can keep protection of your intellectual property, the maps that you build for a certain engine configuration or something like that. Shifting is a pretty simple system, but in the current application it requires a lot of work. You have to have a shift kill box, you have to have something to actually run the shift solenoid, and we're handling that all out of the ECU. You wire the shift solenoid directly into the spares connector. You wire your shift button, whether it be the horn button or an aftermarket one that you put on, into the ECU. The process goes, you request a shift, press the button, and then the ECU starts a series of timers and allows you to fire the shift solenoid to put some load on the gearbox, and then if you have, depending on your transmission type, it'll do a cut or not. One of the unique things about the cut is that we allow you to do an ignition cut, a fuel cut, both, or ignition retard. And depending on the engine, the bike package, some ways are better than others. Some of the turbo guys really like to just do ignition retard. Some of the nitrous stuff needs to do a fuel cut to make it work correctly. So I've built in the capability to do all those different options. And basically the way you select it is just a pull down menu. And I'll give you a glimpse into what the tuning software looks like. Yeah, go ahead.
Can the shift solenoid for the air shifter, can it be activated? Will it send out a 12 volt or a ground, or is it just a ground?
Either one.
Okay.
There's a pull down menu for that as well if you want it normal and inverting. So you can wire it 12 volts and then ground to the ECU, or you can supply 12 volts with the ECU.
Okay, cool.
Which is the case for most of the outputs. You can wire it either way. And then you just have to select which one you've done. Alternately, there's a single value that RPM that you can put in, and if the ECU sees that you're not on anti-lag or a two-step or anything like that, and then there's a series of small delay checks that go on. Once it hits that RPM, it's going to shift for you automatically. One note on top of that is if you need to short shift for some reason and you have the auto shifting mechanism turned on and you press the button, it will still shift. So the button is still a manual override for the automatic shifting system. And then to go along with shifting, you can have basically any type of shift light you want. If you want to put one of those big MSD yellow guys on there, that's fine. We have some can-based lights that do a little bit more than that. It's a shift light, it's a little LED bar, it's very bright, and it also does some additional functions, acts as a warning indicator, acts as, for the guys that have the slider clutches, it'll actually act as a stall indicator as well. It comes up with a couple of little lights. It's kind of cool. We can show you on one of Cecil's bikes, who's been instrumental in helping me get all this stuff put together. I've done a lot of work with him and I've tested a lot of interesting things. Not all of it good. Go ahead. Any questions on the shifting stuff before I move on? All right. Nitrous. We've spent a lot of time on nitrous because of Cecil, of course. I've come up with a pretty interesting strategy. Before I go on with this, I will say that if you go to a kit like this, you're not left out. If you have aftermarket boost controllers or shift controllers or nitrous controllers, those things can still be used. They actually have a really cool advantage of being able to mount that thing on your bike and make changes to it any place up on the starting line if the track's not as good as you thought it was. So those things don't have to be taken off. The ECU can accommodate the AV output signal from a nitrous controller and respond with fuel and ignition that way. So just that being said, we started out doing something that's kind of similar to the way a lot of the aftermarket systems do right now, where you can have a delay timer and then a build time. But what we've done is expanded it a couple of steps, and you can actually have a nonlinear curve, which is what I've shown up here. So your delay time basically is where you start, and then you build that in and you say your delay is where you actually, a 0% duty cycle. This is basically how long we're turning the solenoid on. It does pulse width modulate a solenoid, and there's a couple of servo options out there, and it accommodates for those as well. But for this example, this is the sort of standard pulse width modulated solenoid that everybody's using. This is a two-dimensional table based on lap time. I'm calling it nitrous pass timer, but it's basically lap time. That starts when you let out on the clutch, when you go to full throttle, when you come off of a dual RPM limit. Any of those things will trigger this lap timer to start, indicating this is the beginning of the run. And so basically, instead of just typing in a single value build time and delay time, what you do is you basically just profile versus lap time how much nitrous delivery you want. The really interesting thing about that, and what I've tried to show here, is we can actually hold our nitrous flat at a small duty cycle for a period of time, which is really helpful for the non-wheelie bar bikes and things, where you just give it a little bit of power, you hold that amount of power, then when you have enough wheel speed to pick up some more, then you start ramping it in. You don't have, on a standard delay time and build time system, you delay it, no nitrous, then you turn it on and you ramp it sort of linearly like this throughout that build time. So what we can do now is, this is the most important part of it right here, where you can actually bring on enough nitrous that the bike can handle, hold that, and then ramp it in and control torque versus lap time. One of the other things that we're doing is controlling the frequency, which there's some ongoing testing and it's limited to the solenoid types, but being able to deliver low amounts of nitrous is largely dependent on the frequency that you are pulsing it at. So as you lower the frequency, you can have a little bit better control of the lower duty cycles, the lower, sort of 50 horsepower and below nitrous delivery. Go ahead. Boost control. Boost control is handled in a similar fashion where we have a boost target versus lap time. We do have a lot of compensations in there for inlet manifold temperature, exhaust temperature, things like that to modify your boost for safety, or to actually have it active as you're going down. If the air temperature is high and then comes down, you can feed some more boost into it. If your exhaust temperatures are getting too high, you can take some more boost out of it. And that can be done actively as it's going down the racetrack. One of the unique things about this, actually it's not unique, everybody does some sort of a feedback system, but it is a feedback system. So you say, I want 20 pounds of boost, and the ECU is going to work as you go down the racetrack to try to give you 20 pounds of boost. Can you switch to 2? Or sorry, I2. So what I have here, turn off the values please. So what I have here is a quick example of that. This is a turbo pass. I don't really know it doesn't look like a very good one. But this is our data analysis software. So when you come in, the ECU has data logging in it. You pull the data out of it, and you have, bring up our channels list. Currently, we are logging, this is a development kit, so we're logging 350 some odd channels. Just scroll down through the list. These are all of the different channels that the ECU is currently logging every single pass. So you can get a really good idea of exactly what's going on in every category. All right, go ahead, back to the data here. So we've got engine RPM, throttle position, our mixture, inlet manifold pressure, engine efficiency, which I'll get to, and here's our boost. So this is the ECU attempting to do the control of the boost, and here is the boost trying to hit its target. So you can see PID is a bit of a complicated setup, but the ECU is actually showing you how it's attempting to control boost, and you can see that once it gets out here, as you ramp boost in, our boost target is going up, the ECU is working to hit that boost target actively. That is all what's going on in the background to try to hit a boost target. We got, here's the vehicle lap timer. One of the things, you see it trigger and start here. The rider got out of the throttle, so we're assuming there's some thresholds here. We actually reset the lap timer if you get below a certain threshold. If you stay above the throttle threshold, then it just continues to increment. So we're also got ignition timing curve shown up here. So that's a quick look at what the data logging is doing and how the ECU is working to try to hit a boost target. There's also an anti-lag system. Actually, bounce back to that. Can you go back to the data? The anti-lag system, go back.
Go back.
Yeah, back. Just go back. Alright, so there you go. So the anti-lag system, just to show here, we're actually taking, we want to hit, we have a launch RPM that's desired, we have a boost target that's desired, manifold pressure, can you flip over here? So we're making 30 kPa, this could be turned into PSI, but we're making about 4 pounds of boost or something on the line. What you can see the anti-lag system does mainly is it knocks all the timing out of it. And when you hear these bikes, for anybody that doesn't have turbo experience, they're banging on the line and making all sorts of racket. What's happening here is you're knocking all the timing out of it, and you're sending all that energy into the exhaust through the turbo, and that's what spins it up and creates boost on the starting line. So we call that anti-lag or boost enhancement, and that function is built into the ECU. Here's just a quick example of what's actually going on. You can see that we're actually holding RPM very, very tight up here. Riders at full throttle. Exhaust mixture doesn't make any sense when you're anti-lag, but One thing to notice also is that we have a boost target still, and the ECU is working actively to try to hit that boost target on the line. So not only do you retard the timing, but the ECU is still trying to hit a desired manifold pressure. Okay, back to the presentation, please.
Drake,
Yes.
you said you can have it, you can convert it to kPa. Can you ask the controller to show it in pounds, or do you have to have a conversion table?
No, you can actually ask, you can change the units in the tune program to be in pounds.
Okay.
Yeah, the company is an Australian company, so you're going to see that by default this stuff comes in metric units, but you have, switch to the tuner real quick. Just go over here and right click on manifold pressure, and then go to channel properties. So you can select what your units want to be over here, so just change it to PSO. Alright, okay. Now you see we're actually going to display this in PSI instead. That's all that's required. Alright, go ahead and go back. So, any questions on boost control anti-lag? Alright, moving on. The fuel model. This is a bit of a complex subject, but I want to touch on it because there's some really cool benefits to it. What we've done now, and anybody that's used a lot of aftermarket ECUs, but also our M800s, our previous stuff, you have an injection pulse width table that doesn't really mean much. It's just how much fuel do you want to deliver. It has nothing to do with the characteristics of the engine or anything like that. So when you make a change, you put new injectors in it, you have to retune it for those new injectors. So what we've done now is done more of an OEM style. That's going to be a little bit like what you have if you leave the stock ECU on it, where we actually tell it the characteristics of the engine. We tell it the engine size, fuel pressure, injector size, type of fuel, and a few other parameters, and then the ECU actually calculates how much air mass it's going to get. And the main fuel table is called engine efficiency, volumetric efficiency. You know, it can be, there's a few names for it. And what that is every engine makes somewhere in between, depending on how good or bad it is, 85 to slightly over 100% volumetric efficiency at full throttle. Where that occurs is peak torque. So you're, switch to tuner real quick and go to the engine efficiency table. What you're going to find, I'll just go to the search bar and do it right here, engine efficiency. And F6. Alright, so what you're going to see here is this is our engine efficiency table. This one needs a little bit of work. But you're going to find that it matches your torque curve, because the max cylinder filling of an engine occurs at peak torque. So your peak volumetric efficiency is always going to be at peak torque. So what you'll find is that when you look at this curve versus the torque curve, they're going to be almost identical. And the nice part about that is you can actually predict what an engine map is going to be, knowing a few characteristics about the engine. And you can put in something, if you put 100% in this table in full throttle, you're going to be close enough to be able to go out and run. Now, that being said, it is the appropriate strategy to put it on a dyno and map it for the characteristics of your engine. The cool thing about a fuel model is you really only need to do it once. Because if you go to the racetrack and you change fuels, you run out of whatever you've got and you go buy whatever somebody else has, you just need to tell the ECU what kind of fuel you put in it, and then it'll make the appropriate adjustments. And that even extends to the extremes where you have gas in it and you want to make a run, you've got a grudge bike and you want to make a run and you want to put some methanol in it. If you tell it that you just went from gas and now you have methanol and your injector can handle it, it will be able to sort out a methanol bike with just changing the fuel type. And we've actually done that and it works. The other things that you can change injectors, you can change fuel pressure, you can change basically anything inside the fuel system if you have a fuel pressure sensor on it and it fails. the ECU is going to make the appropriate corrections based on knowing what your static fuel pressure is. All that stuff can be handled without having to go back to the dyno and remap the engine. It also means that you can make changes to your bike. Just tell the ECU the few changes that you've made and you keep going. There's not a lot of extra time and money and effort that needs to be spent in recalibrating everything. Back to the presentation. Any questions about this? I can go into the details of the equations and stuff that we use to calculate all this if anybody has that question, but we can deal with that later. Gets pretty complicated. But you never have to worry about it. That's my job. Next one, please. Data logging. We saw a little bit of data log from the turbo bike, but one of the things I'd like to point out on the data logging is that we've had some really good feedback from people that have reluctantly got into this to a standalone ECU, and then were quickly turned around by the fact that not only is their bike repeatable, is it reliable, but they also learn how to ride. I really enjoy the time when you get somebody that's new at this and they swear up and down that they've done something riding the bike, and you come back and you show them the data log. Look, dude, you're only at 60% throttle, you rolled off, and he says, no, I was at 100 the whole time. No, you rolled off twice actually, and you turned off the nitrous because you know I was on it the whole time. There's something wrong with my engine. I mean, just it's awesome actually. And then people would start to believe it. They're like, this is really what's going on. The next time they go out there and they lock the throttle and they pick up 2/10 just because they stayed full throttle, and they start learning how to ride. It's actually a really cool secondary benefit of the data logging that goes on inside the ECU. Taking that a step further, if you have an all-in-one system where you're controlling everything, you can link that and know that not only did I roll off the throttle, but I rolled off so much that I turned the nitrous system off. And another thing here is that my reaction, this is a wheel spin and a wheelie example here. So we're looking at engine RPM, rear wheel speed, throttle, nitrous, the pass timer, and the shifter. So the reaction to this wheelie and spin is the rider rolled off the throttle, but prior to rolling off the throttle, he requested a short shift. And so you can see that you can really profile exactly what the rider is trying to do and what the bike is trying to do at any given time. That's one thing that you can't do if you've got 4 or 5 different systems on there. You may have requested a short shift, but you have no idea when it was and if it actually happened. So with this system, you can see that the rider's reaction is shift, then throttle. So you can start learning how to ride better just by looking at the data as a secondary benefit to being able to tune the engine and tune the chassis. Go ahead. And here's a bit of vehicle data. This is engine RPM, although it doesn't look like it. We have wheel speed. This is an example of just some of the other chassis sensors that you can put on to start collecting more data on what the vehicle itself is doing. We have a serious wheel spin problem, and you can see the wheel speed ramps up and then comes back down. What we're looking at down here is this orange line is track temperature, and then the 2 blue lines here, or blue and gray, are rear tire temperatures. So we can do things like you can look at your burnout, how long you do a burnout versus what the track temperature is, and see on days where you have, you know, the most amazing 60-foot time you've ever had. You can see what the track temperature is, and then you can see what the temperature was, how much you heated up the tire, and start learning things like the correlation between the tire and the track and what gives you most grip. Depends on how intense you want to get into it, but you can use things to start learning like that. One of the things on big tire bikes, or even what we've done before is if you have enough spaces, you put 3 of them across the tire. You can actually find that a lot of riders just naturally will lean to one side, and they'll only heat up one side of the tire. Or if you put one on either side, you see the guys that, you know, they're trying to heat up the outside of the tire, but they only do it very well on one side. So you don't have even temperature distribution across the tire when you try to launch. All that can be run into the spares connector, and those sort of other sensors can be logged to start teaching you more about what's going on with the vehicle aside from just the engine running well. So all this is done through a program we call M130. This is a free program. It's on our website now. You can go download it. We don't charge for software, so you're not gonna get a system like this now and then have to pay for the next version. As we make improvements, they go up there for free, and you have access to it. That's the way it's always been. For MoTeC, we don't ever have our software is sort of built into the cost of the hardware. So you don't have to have any dongles. You don't have to have anything else. You can go download this. You can go download an example package. I can give you the example package that's in here, a start file. You can play with it to your heart's content. See if you can figure out how to use it. What we have a series of gauges. This system can be run live. You can plug it into the bike while you're warming it up in the morning, while you're on the dyno. You make all your changes live, and they get saved in the ECU right there. You don't have to flash chips or anything like that. You just plug into it. We actually have one. Can you open that one up? We actually have one running on a simulator here right now. So get rid of those fuel cylinders. Give me some engine RPM. You can see right here we actually have, this is sort of hit F6. You can see that it has a live screen, so you can see the engine doing 1.7A. We got to change our F-Sync setup for that. But this is how the system runs live. You can add channels. Click on this channel list over here. You'll see that the data analysis program I had up earlier and this one, they look almost identical. This program was built off of the other one. So even though there's two separate data logging and interface programs, their functionality of them is almost the same. So you really only have to learn one program. Any of these channels can be put in here to watch live. So give us like fuel volume or something like that, fuel volume primary. Drag a new channel in. Now we can actually see that if we change manifold pressure, you can see that our requested volume is going to change along with it. So you can go through and actually see this live when you're running your vehicle and make changes and see what happens. Go ahead and F6 and get back out of there. And back to one of the other things to note here that I didn't touch on is the warning system. The ECU will actually give you diagnostic errors. If it detects, if you plug into the ECU before you go run and it detects that fuel pressure is faulted, it's outside of range, it's going to flash at you and say, look, well, you've got something going on wrong here. And then hit F3. And then you hit one key and it says, okay, here's the status of the system. Currently the ignition's off. We have a calibration maximum on our fuel pressure sensor. That's unique. Lucky. And so you can actually say, look, I can't run this thing until I figure out what's going on with my fuel pressure, because fuel pressure is actively, if it's on the system, it's an active part of the fuel mode. So it's important that you don't have an error of an incorrect value. So the ECU quickly tells you that there are problems with the system, and you can come in here and check them real quick. Go ahead and close that. And then if you go to channels, you go to fuel pressure, and F6. F6. There you go. So now we can actually see what our raw voltage is, what it thinks that manifold or fuel pressure is right now, and it says, 4.5 volts is the maximum measurement of most pressure sensors. So it's saying that we're reading a value that's higher than what the maximum of the sensor is, and you should expect that possibly this value is wrong. All right, let's go back to the presentation. Next one, please. A couple of cool tuning features is quick lambda and W lambda is what we call it. When you're tuning, as you're sweeping through, you can actually press one key as you're tuning, and it will correct the fuel map for you. It'll look at what your current lambda value air fuel ratio is versus your target air fuel ratio, and it'll readjust the map to hit that target. If you're hogging on a map, if it's a new engine, you don't have a map that's anywhere close to it, there's a W function that'll actually help with interpolation problems. I can explain that in more detail if somebody has a question on it. The neat thing about it is there's just a one click correction on the keyboard. You can just sort of go through a sweep and just click this one key, and it'll correct everything as you go along. It can be done live during a dyno pull if you want to. I've had some engines making 2,000 horsepower that from scratch. I have the dyno operator on an engine dyno, hold it at 3,000 RPM, work up to 100% throttle, and then make a pull. And we do that straight away. We don't have to work through part throttle sections of the map. You can get right into the heart of what happens. 2 pulls, the fueling is done, and we can start moving on to timing. So this is a really, really useful feature. If you have idle variations, you start up, it's not idling quite right, your lambda sensor is showing that it's too lean, hit Q a couple of times, it'll richen right up to where it needs to be, and you're all done. Next one, please. This one is actually a kind of a cool feature. So go to the data real quick. It's a post-processing. It does the same thing, but it's post-processed. So you can look at the data. Let me scroll over here to something. So right now we're at 9,000 or 10,000 RPM. We're asking for a value of 8.6. We actually have a value of 8.5. So go to 2. And go to the engine efficiency table. There we go. Click on engine efficiency. There you go. F6. So go to 9,000 or 10,000. Putting her on the spot. I didn't tell her I was going to do this. Okay, so go up to 100% throttle and hit L. L says you've asked for a 0.9. What is the value in the data? Do a 0.85. Okay, apply. Now you see that value changed from 133 to 125. So you can go through a data logging file and tell it what the air fuel ratio was at all those points in the data. Just tell the ECU what it was, and it'll correct the fuel, so that the next time it is correct. You don't need to go back on the dyno. You just need to have a data logging run. All right, back to the. Next one. Calibration. The Q key on the keyboard is also useful for calibration stuff. The example I have up here is throttle position. If you go to throttle position and you go, just leave it closed, hit Q, and then you go to wide open, hit Q, it'll calibrate the throttle 0 to 100%. That's all that there is to it. One of the things that I've tried to do with this system is make it powerful, be able to do everything, but I've also tried to make it easy to use. One of the ways I've done that is I've created my next version, this is a little bit older, is 2 user logins. You actually log into the ECU very similar you do to Windows. It'll say what user do you want. You have a pull down menu, say I'm Drake, and then it asks you for a password. What this thing's going to do is it's actually going to have standard and advanced. So if you're a standard user, you're new to it, don't be intimidated by the 1,000 channels that are in that list. I've broken all that down to only the things that you need to use on a frequent basis. So you log in as a standard user, that list goes from this big to this big. It only has the tables that you adjust, the fuel tables, nitrous tables, boost tables, things like that you're going to want to use from a run-to-run basis. If you have some sort of an issue and you need to get to more advanced settings, then you can log in as an advanced user, and then the list gets this big again. So I've tried to really make, yeah.
if you made a pass and you were previously in standard mode, but you want to view the data in advanced mode, did it data log it still?
Yes, it doesn't affect the data logging side of it at all. It's basically just a filter to take away all of the available options and shrink it down. I was actually going to try to hide a bunch of that stuff in the background so it's not even visible, stuff that you'll really never even need to mess with. But what the problem with that was going to be is that it was also going to shrink your capability. It was going to start limiting you to having whatever you wanted on your bike and be able to set up the system to do it. So I started out that route and then decided against it. I didn't want to stop creativity from anybody's standpoint. I know everybody's trying to get an edge, and that's what it was going to keep from doing. It would have made the system dead simple to use, but also it was going to clamp it down pretty hard. So I opted against it, and I'm doing the user login. And I'm not controlling the advanced password at all. It's going to be available to anybody. It's just your choice what level you think you're at. Go ahead. We got into this a little bit. All this is showing you, I didn't do this live yesterday, so you guys got a little bit better presentation where it shows you raw voltages and things like that for the diagnostic and troubleshooting side of the system. You can monitor all of the things that live in the ECU, which I sort of showed you. Go ahead. And then we went through the errors and statuses. Here's another, the other one showed us a calibration limit. This one actually is saying that we have a fault on the sensor. And what it does is if it faults out, you put in a default value. Air temperature, for example. If air temperature faults out, you put in something that's reasonable, 20 degrees C, 60 degrees F, and that's going to be good for a range above and below. If you want to be real creative with it, you actually would put in a default value that's representative of what the actual temperature is that day or some part of a day, and it'll be more accurate if you have a fault. Otherwise, you can put a reasonable value in there, let Lambda control sort the rest of it out, and you're just fine to go. I just put in here a process. I don't want to intimidate anybody. This thing does a lot of stuff. It needs to do a lot of stuff to be able to take over the capability of all the electronic modules that go on some of these bikes, all in one unit. So what I suggest as a process, if you're sort of new to fuel injection, if it's something that you think you want to get into, I would suggest get into it, take it to a tuning shop, somebody that has experience with it. Let them put it on, let them do a base calibration for you. Cecil at HTP, or whoever gets this, is going to do it for free. For somebody, you can take your bike there and he'll install a system, calibrate it, give you something to go to the racetrack with. And then I would start with working on the data logging side. Because the two programs are linked and identical, or very similar in functionality, start downloading some data. Make laps and start downloading data. You'll learn how to use both programs by doing that, and then get into doing some simple adjustments. And then as you get comfortable, you can continue to get deeper into the system, what it does, add more functionality to it. And this system, just because I keep coming up, I get feedback from people, I come up with my own new ideas, is going to evolve. I'll add, if a new product comes onto the market that the ECU doesn't control correctly, I'll get one, I'll buy one, and I'll put the control into it. So if people start coming to me and saying, hey, we want to start using device X, whatever it is, I'll get my hands on one and I'll add it. That'll go up as a revision to the package, and it's not going to be, there won't be a charge for that either. It'll just be a new revision, and you'll get access to it. So we're going to continue to develop this thing. We're going to put new capability in it. We're going to work to cover more bike options as they come out. We're going to try to keep up with the market because the system is much more advanced than what we're doing with it right now even. So I welcome feedback from anybody as far as things that it would need. But I would say a good way to do it, you can, like I said, all this stuff, the i2 software I showed you, the Tune software is free. So you can download them. There's example files with both of them. You can get in there and have a play and see if it's something that you think you want to tackle. But that's a good, excellent place to start.